Hello, this is Mrs. Myers. We are going to be learning about congruence in right triangles today. We have already learned about congruence in other triangles using SSS, SAS, ASA, and AAS postulates. Those are the congruence postulates that we've learned about angles and sides. When it comes to right triangles, there was a certain postulate that we learned that did not work. And if you remember, we said there's really one special case that the SSA postulate does work. I have it written here. Remember, HL is the special case of SSA. We said SSA doesn't work. It's a bad word, right? But there is one case, and that's if the angle is a right angle. In other words, if the triangle is a right triangle. So this is called HL postulate. The H and the L come from these two words, hypotenuse and legs. So this is important vocabulary. In right triangles, the parts of the triangle have special names. The two sides that come together, they actually look like the letter L because they come together to form the right angle. Those are called legs. So the ones that make the L are the legs. The other side is called the hypotenuse. So the right angle is always pointing at the hypotenuse. Okay? The hypotenuse, another way to say it, is that it is the side across from the right angle, opposite from the right angle. So the two legs form the right angle, and the hypotenuse is the one side that does not touch the right angle at all. So those are special words that we only use with right triangles, especially hypotenuse is only used with right triangles. Okay? So the hypotenuse leg theorem says if the hypotenuse is congruent to the hypotenuse of another triangle, and either one of the legs is congruent to one of the legs of the other triangle, as long as the two angles are actually right angles, therefore we're dealing with right triangles, then the whole triangle is congruent. So with these postulates, SSS, SAS, etc., we always needed three parts, three sides, two sides and an angle between them, two angles and a side between them, or two angles and a side not between them. But here we only need two parts to form our H and our L. However, even though the name only has two letters in it, we really actually do need to know a third part because we have to know that that angle is a right angle. Okay, so in this diagram, if we know that the hypotenuse is congruent to the hypotenuse and the leg is congruent to the leg, and they are both right triangles, then we could say the two triangles are congruent. So let's say triangle PQR is congruent to, now remember we have to watch our order. P corresponds with X, so X, Q was the right angle, Y is the right angle, Z, X, Y, Z. Okay, so again, HL is a special case of SSA. If you look at this diagram here, right here, this helps to illustrate why SSA does not work. So if you look at this diagram and try to think back to the activity that we did with the straws and the angles, right? And if we set this as 5, and we set this as 5, and we set this as 45 degrees, and this is 45 degrees, and our other side has to be 4. Remember we had extended this like a dotted line? And then when we had our length of 4 drawn, that length could actually rotate oops, rotate and touch the, it's not going to let me move now. Okay, and touch the dotted line at another place. Okay, well, like that. Okay, so that length of 4 made 2 different triangles. So this is illustrated in 2 different, instead of swinging it, the 4 goes to here, the 4 goes to here. So SSA, side, side, angle, not between them, and side, side, angle, not between them, didn't guarantee 2 congruent triangles. This triangle is not congruent to this triangle, even though they have SSA in common. So that's why SSA did not guarantee triangle congruence. If you remember with our straws and angles, we proved that it didn't work. So the only time SSA works is when you're dealing with an A. This A is a right angle. Okay, so for HL theorem, you have to have 2 right triangles. The triangles have to have congruent hypotenuses. And there is 1 pair of congruent legs. So even though HL is called HL, which has 2 letters in it, there's actually 3 pieces of criteria that have to be true. So when you're doing a proof, you must have all 3 statements stating those conditions. So let's work through this proof here. Given that angle WVZ, now I look at this diagram here and I would like to separate out my 2 triangles. So I'm going to take VWZ and I'm going to move this to here. So you might want to just draw that separately and then take the other triangle and draw that separately. When they overlap like that, it's a good idea to draw them separately. Okay? Remembering that if they overlap, they do share a side. So we'll talk about that in a minute. Okay. So what we are told is that WVZ and VWX are right angles. So we're going to mark those 2 right angles. We also know that WZ is congruent to VX. So we have to mark those as congruent. We're trying to prove the 2 triangles are congruent. So first let's state our given. WVZ and VWX are right angles. That's given. Therefore, notice the difference here between 1 and 2. This says triangle WVZ and triangle VWX are right triangles. So this one was angles in part 1, and statement 2 is saying, okay, well, if those angles are right angles, then I mean these triangles are right triangles. This is going to be by definition of right triangles. A right triangle is just a triangle that has a right angle in it. Okay, so step 3 is also a given. So we're going to put WZ is congruent to VX. Those are the hypotenuses that are congruent. Notice the hypotenuse is across from the right angle. So this side here is not touching the right angle. That makes it the hypotenuse. And this side as well. So those are the 2 hypotenuses are congruent to each other. So we have that the H's are congruent. We also have that the triangles are right. So when we look at this criteria that I was talking about before, conditions, there are 2 right triangles. The triangles have congruent hypotenuses. So there's just one more piece that we have to prove. We have to get that 2 legs are congruent. So if you look at this diagram, since they were overlapping to begin with, they actually share side VW. So VW is part of this triangle, and VW is also part of this triangle. So since VW is congruent to VW, we use the reflexive property. That means that we have a leg congruent to a leg. So at this point, we have all the criteria we need. Oops. That third piece we've got. And we can say that the two triangles are congruent by the HL theorem. Okay, so when you're doing a proof for congruent triangles, if they're right triangles, check and see if you have two hypotenuses congruent, two legs congruent, so that's two congruent statements, and if you can state that they're right triangles. Those are the three things that we got to have in our proof before we can use HL. Okay, so if we look at this next page, state if the triangles are congruent, then state why you know. So if this is a right triangle, a right angle, and it's vertical angles to this angle, we can mark them both right angles. When we, remember, we're going to kind of cover up one triangle. I can't do that on the video, but let's just cover up one triangle like this. Once we have everything marked, right? Look at what we have. Do we have a hypotenuse? No, we don't have a hypotenuse. We have two legs. So, is this HL? Nope. Let's unveil this now, right? We have one leg congruent to another leg, and then the second leg congruent to its corresponding leg, and we have right angles. So, this is actually SAS, side, angle, side. So be careful. You're not going to look at a right triangle and think, oh, it's automatically going to be HL because it's a right triangle. It's not always HL, right? Sometimes the angle in SAS is a right angle. Sometimes an angle in AAS is a right angle. But the only time we can use HL is if we have right triangles and a hypotenuse to a hypotenuse and a leg to leg. So let's look at part B. If we look at this using S's and A's, we would go, oh, it's an angle and it's a side and it's another side. That's SSA, which is bad words backward. So then we would have to say, okay, well that won't work. But look at our angle. Our angle is a right angle, so that might mean it's HL. So hypotenuse to hypotenuse, that's the side across from the right angle, and leg to leg, so this one is going to be HL. Okay, look at C. See, they share a side, so we can automatically mark that by reflexive property. Now, remember, do we have everything marked that we possibly can mark? If we do, we're going to kind of cover up one of the triangles. I'm covering it the best I can here. And look at what you have marked. You have a right angle, you have another angle, and you have a hypotenuse. Is that HL? Nope. This one is going to be two angles and a side not between them, so that's AAS. The side is not between the two angles. AAS. Okay, now let's look at part D. Part D, we have an angle congruent to an angle, and we have a side congruent to a side, and we have another side congruent to another side. So when we look at these two triangles, do we have a right angle? Nope. So it's not going to be HL. This one you have to be careful. When you cover up one of the triangles, over here we have SAS. But if you cover up this triangle, over here we have SSA. So they don't match. If they don't match, then we can't say these triangles are congruent at all. So no conclusion. Okay, so when you're covering up a triangle, you want to make sure first that both the triangles are marked the same way. So maybe cover up one triangle and then cover up the other triangle so that you can check and make sure that they both are saying the same thing. Okay, here's a flowchart proof. Flowchart proofs are actually just another alternative to two-column proofs. Instead of making the statements and the reasons like this, you can start with your givens over here on the left. The given says BE bisects AD at C. Let's look at our diagram. BE bisects AD. So the thing that's getting cut in half or bisected is AD. So we can mark these two things congruent. So in a flowchart proof, that given, put our given underneath, leads us to be able to conclude, right? Since this bisect, we know what bisect means, leads us to be able to conclude that AC is congruent to CD or DC. So they mark this given leads directly to this conclusion. So we can state that conclusion by the definition of bisect. Okay, so instead of statement, statement, statement all underneath each other, now you're kind of linking what givens lead to what conclusions. The other given says AB is perpendicular to BC. AB is perpendicular to BC. Well, that means this has to be a right angle. So that given directly leads us to conclude that there's right angles here and here. Reason? Definition of perpendicular. That's how we know that those are right angles. Well, then you can say, well, if those are right angles, then the triangles must be right triangles. That's by definition of right triangle. Okay. The other piece of given is here. AB is congruent to DE, that's given. So let's look at what we know in our diagram. We know that these are right angles. We know AC congruent to CD. And we know one leg congruent to another leg. So AC and CD are hypotenuses. So this is going to be right triangles, check. Hypotenuses, that's the H, check. And leg, check. So now we could say the triangles are congruent to each other by HL. Okay, this last page I'm going to have you try on your own. What additional information would prove each pair of triangles congruent by the hypotenuse leg theorem? So you have to kind of look here and say, what did they tell us and what else would I need to know in order to use HL? So use your checklist. H, L, and right angle. Those are the three things you need. So in this number 5 here, do we have an H? Nope. Do we have an L? Yep. Those are the L's, right? Do we have a right angle? Yep. Okay. I don't need to mark those L's, right? Those are L's. So what are we missing? We're missing a hypotenuse, right? So what would we have to be told in order for us to use HL? What are we missing? We would need AC congruent to DF. And those are the H's. That's what we would need to know. Okay, so follow that same logic here, that same checklist. Check for an H, an L, and 2 right angles, and see what's missing in those. Down here, what values of x and y are the triangles congruent by HL? So in other words, assume these are congruent, what would go with what? So make sure you name hypotenuse to hypotenuse and leg to leg. I'm going to say just set this up. Set up the equations. Solve if you know how, but it's going to be a system of equations. So you're going to use either substitution or elimination. So try that one. If you can't solve it, at least set up the equations. Okay, thank you.